So by now we're probably on about the fourth video for differentiation, and we should be really confident now about the concept that differentiation finds the gradients. But as we've seen in the graph section, sometimes the graphs do something that's a bit odd, and those bits are called, sometimes they're called turning points. So if I had a graph that went up to a maximum point or dropped down to a minimum point, or sometimes got to a point of inflection where the graph kind of stops, and then carries on going up, those are all called turning points, and at each of those the gradient is 0. So you can use the differential function to find out where these turning points are, because you can get it to say, right, the gradient's 0, work back and find out what x is, and then from there you can work out what y is and what have you. But we can also determine the nature of the turning point, because if I go a little bit left and a little bit to the right, to the left my gradient here was increasing, and to the right my gradient was decreasing. And if I go a little bit to the left and a little bit to the right of my minimum, to the left my gradient was decreasing, and to the right my gradient is increasing. And my point of inflection before and after on that one, my gradient is increasing, and before and after on that one my gradient is decreasing. So by knowing this rule, that if it's a maximum it goes positive gradient, 0, negative gradient. If it's a minimum it goes negative gradient, 0, positive gradient. And if it's a point of inflection it's positive, 0, positive, or negative, 0, negative. I can now use that fact to determine, without even drawing the graph, what the nature of these turning points are. Okay, so this session was purely theoretical. The next video will explain how to actually do that process.